So, hi guys, welcome to Placements Ready. Today's problem is implementing Dijikstra's algorithm. But before moving on to the problem, if you haven't subscribed our channel, please subscribe. That really motivates us to create such amazing content, right? So, we are given a weighted, undirected, and connected graph of V vertices and E edges. Find the shortest distance of all the vertex from the source vertices, right? And also, the graph doesn't contain any negative weight cycle. So, that is fine. So basically, Dijkstra's algorithm is also known as single source shortest path algorithm. Basically, what it means is that we are given a source vertex and we have to find the distance of all the vertex from a given source, right? So I hope you have understood what this algorithm is. Now let's discuss the example input. So here, as you can see, the source is 0 and the distance of 1 is like 9. So the distance of 0 from 0 is 0, right? And the distance of 1 is 9. So that is fine. So we have to return a vector containing the distance of all the vertex from the source, right? And similarly, here you can see the distance of 1, or basically here 2 is the source. So distance of 1 is going to be 3. Distance of 0 is going to be 3 plus 1, which is 4, right? So distance of 0 is 4, distance of 1 is 3, and distance of 2, which is itself, will be 0, right? It is understood. So I hope the problem statement is clear to you. Stay till the end of the video, right? Now I will be discussing the explanation part. So for explanation, I have taken this graph, right? So what we need to do, like there are two methods. One is using set, but I prefer priority queue method because it is somewhat easier to understand, as well as in implementing it is much easier, right? So what we will be doing, first of all, we will be needing a distance array, right? So distance array will be initialized to int underscore max. Why? Because initially we will assume that every node is having a distance of int max from the given source vertex, right? So that is fine. So here we are having 6 vertices. So 0, 1, 2, 3, 4, 5, right? And initially it all will be infinity. Now we will be needing a priority queue. So priority queue will be containing the distance comma node, right? So that is fine. Now see, let's say our source is 0. So what we will do, we will push the source with a distance of 0 in the priority queue, and we will update the distance of source from infinity to 0. The first step is that. Now we will iterate on the priority queue, right? So if I write down the step, first of all push the source into priority queue, okay, and initialize the distance to 0. So that is fine. Now we will take out the element from the priority queue, which will be the top of the priority queue, right? So that is fine. Now see what we will do here. 0 has two neighboring nodes, which is 1 and 4, right? So till 0 the distance is 0, and till 1 and 4 are its neighboring, right? So 0 plus 1 is 1, right? So that is fine, and 0 plus 4 is 4. So now we will check if distance of 1 is, like, whatever be the distance of 1 in the distant array, right, is greater than the current distance, which is 1. So we will update this. So infinity will be updated by what? It will be updated by 1. And now we have got a better candidate, right? So we will update the distance to be 1, and we will take out this and we will push 1 with a distance of 1. That is fine. Now 4 will be pushed. So 0 plus 4 is 4. So 4 is better than infinity, so we will update this distance, right, and push 4 into the priority queue. So 4 has a distance of 4, right? So that is pushed. Now 1 will come out, right? 1 will explore its neighbor. 1 has only one neighbor, which is 2, and as well as 0. But if you go on to 0 from 1, the distance will be 1 plus 1, which is 2, which is not better than 0. So we will not update it, right? But we are going to definitely update the distance of 2, because 1 plus 1 is going to be 2. So that is fine. So यहाँ पे क्या होगा, इन्फिनिटी से अपडेट होकर 2 हो जाएगा, राइट? एंड हम लोग क्या करेंगे अब, क्योंकि ये दोनों बाहर आ चुका है हमारे प्रायोरिटी क्यू से, तो इसे डिलीट कर देते हैं और प्रायोरिटी क्यू के टॉप पे क्या आ जाएगा, 2, राइट? एंड बाय द वे इट विल बी अ मिन प्रायोरिटी क्यू, ठीक है? तो पेयर टाइप का बनाएंगे प्रायोरिटी क्यू एंड मिन प्रायोरिटी क्यू बनाएंगे. सो दैट इज फाइन. सो 2,2 आ चुका है. नेक्स्ट टाइम क्या होगा, 2 को हम लोग बाहर निकाल लेंगे प्रायोरिटी क्यू से, राइट? अब 2 के नेबर्स को एक्सप्लोर करो. तो 2 का नेबर 1 है, 3 है, राइट, एंड 4 है. तो 2 से अगर हम लोग 3 पे जाते हैं तो अभी तक का डिस्टेंस 2 था और प्लस 2 विच इज 4. तो 3 ऑल्सो हैज अ बेटर आंसर, राइट? तो इसे अपडेट कर देंगे और यहाँ पे पुश कर दो, है ना? दैट इज फाइन. अब 4 पे अगर हम लोग जाते हैं तो 2 प्लस 2 इज अगेन 4, राइट? बट वी डोंट नीड टू अपडेट इट बिकॉज 4 इज ऑलरेडी इक्वल टू 4, ये जो आपका डिस्टेंस है, राइट? देन एक इसका नेबर 1 भी है, तो आप अगर वापस जाओगे इस पे तो 2 प्लस 1 इज 3, तो दैट इज नॉट बेटर, राइट? तो वी विल नॉट अपडेट इट. नाउ 2 का काम हो गया हमारा. नाउ 4,3 आएगा, राइट? सो टिल 3 डिस्टेंस टेकन इज 4. अब 3 का नेबर कौन कौन सा है, 2 है और 5 है, राइट? तो 2 पे अगर वापस जाएंगे तो 4 प्लस 2 इज 6, तो उसे अपडेट नहीं करेंगे, है ना? 5 पे अगर जाते हैं तो 4 प्लस 5 इज 9, तो 9 इज बेटर देन इन्फिनिटी, तो इसे अपडेट कर दो 9 से. तो ठीक है. और एक काम करो, 9,5 को पुश भी कर दो प्रायोरिटी क्यू में. तो ठीक है. तो अब हमारा 3 के लिए काम हो चुका है. नेक्स्ट टाइम 4,4 आएगा, राइट? अब 4,4 का नेबर कौन कौन सा है, 0 है. 0 पे वापस जाएंगे तो 4 प्लस 4 8 ले लेगा यहाँ पे, राइट? 4 से अगर 2 पे जाते हैं तो 4 प्लस 2 6 होगा, बट 2 का डिस्टेंस क्या है हमारा, 2 है. तो 6 इज नॉट बेटर देन 2, तो हम लोग अपडेट नहीं करेंगे. अब 4 से हम लोग 5 पे जा सकते हैं, तो 4 प्लस 3 इज 7, राइट? तो 5 का आंसर अभी तक 9 था, है ना? तो 9 से बेटर है 7, है ना? अगर हम लोग शॉर्टेस्ट डिस्टेंस की बात करें तो हम लोग अपडेट कर देंगे और हम लोग क्या करेंगे, प्रायोरिटी क्यू में 7,9 को पुश कर देंगे, राइट? सो डेफिनेट इन दिस वे ओनली आवर एल्गोरिदम विल रन, ठीक है? तो 5 के लिए अब कुछ भी अपडेट नहीं होगा, इस वाले के लिए भी कुछ भी अपडेट नहीं होगा. तो फाइनली हमारा डिस्टेंस अरे क्या बना, तो 0 का डिस्टेंस हो गया हमारा 0, राइट? फिर 1 का डिस्टेंस 1, 2 का डिस्टेंस 2, 3 का डिस्टेंस 4, 4 का डिस्टेंस 4 and 5 का डिस्टेंस 7, right? So this is our answer and this we have to return. So that is fine. Now let's discuss the coding implementation. So as you can see, like I have taken a vector which we need to return, right? And I have named it as distance, okay? And initially it will be of size v and all of the elements will be initialized to int max. Why? Because initially we will assume that every node is going to be at a distance infinity from the source. Now we will be using a priority queue and it is a mean priority queue. So mean priority queue को ऐसे लिखते हैं, right? And it will be of type pair of int comma int. So it will be storing the distance as well as the node. So first of all, what we will do, we will push the source, right? And source will have a distance of 0 from the source, right? And we will update the distance of source to be 0. Now we will iterate on the priority queue till it is not empty. Now what we will do, first of all, we will take the top element of the priority queue, right? And the node will be nothing but p dot second, right? The second value is the node value and current distance is p dot first, right? Now we will be iterating on all the neighbors of the current node, right? And we will check if the neighboring distance, right, plus the current distance is less than distance till now, right? Then we will update it and we will push our element into the priority queue, right? So this was how we can implement Dijkstra's algorithm. So I hope you have understood the logic as well as the implementation part. Just in case if you understand, please like this video and subscribe to our channel for more such amazing content. Thanks for watching.